Hello everybody, I will start my today another live session. So today I solve this question, copy list with random pointer. So in this question, a linked list of ranks n is given such that each node contains an additional random pointer, which could point to any node in the list or no. Construct a deep copy. So you can see here, it's a linked list. So next pointer exists and also it has the random pointer. Yeah. Construct a deep copy of the list. The deep copy should consist of exactly n brand new nodes where each node has its value set to the value of its corresponding original node. Yep. Both the next and random pointer of the new nodes should point to the new nodes in the copied list, such as the pointers in the original list are copied list represent the same list state. None of the pointers in the new list should point to the nodes in the original list. Okay. For example, is there two nodes x and y in the original list where x dot random is pointing to y, then for the corresponding two nodes x and y in the copied list, x dot random should be pointing to the y which is copied. Return the head of the copied linked list. The linked list is represented in the input output as a list of n nodes. Each node is represented as a pair of bar random index where bar is an integer representing node.bar. Random index, the index of the node from range and 0 to -1, that's the point random pointer point 2, or null if it doesn't point to any node. Your code will only be given the head of the original linked list. Yeah. The linked list is present. Yep. I see. So in this example, input is represented as this list, but actually, what I'm giving is the node. Okay, so let me start with the clarification. So in this question, I'm giving a node class, which is the head, and I will return the node, which is the head of the copied linked list. Yeah. And as a constraint, I'm wondering if this node head can be null or not. And I check it. And yes, it can be null. Because n is the number of nodes. Yeah. Okay. Aside from that, I'm okay with this. So let me take a look at the examples. So let's say I'm giving three list looks like this. Actually, this is pointing to null. And let's say one is pointing to 3. And also 3 is actually pointing to 2. Yeah. And also 4 is pointing to 2 also. Okay, so in this example, definitely I should return something like this. Yep. And I will think how we can copy this list. So the approach I can take is completely copy the linked list. Yep. So I can use the kind of 2 pointers, moving from the original nodes and also moving, across the copied linked list. Yeah, as building it. Then I will have the hash map and create hash map from original node to copied node. Yep. Then in the second traversal, copy the random pointings. I can do it because For each node, I'm traversing each node in the current, you know, um, I mean, original node. Like I'm moving here. Let's say I'm at node 1. In that case, it has the random pointer to node 3, and I can map this node 3 to the copied node 3 here. And also I do traversal on the copied linked list 2 at the same time. So yeah. So now I have the, I mean, I know that the node 1 should be pointing to node 3 as the random pointer. Yeah. And I have the access to this copied node, so I can just pointing one dot random to this node 3. Yep. I think this is possible. So in this way, the time complexity should be O of n, assuming that there are n nodes in the given linked list, because I do the 2 pointers twice. Yeah. And for each, I have to traverse from the head of the original linked list to the tail. Okay. And for space complexity, aside from the return linked list, copy the linked list, I need the hash map, which takes O of n. Because as I can see, I have the mapping from original node to copied node. There should be exactly n items in this hash map. There should be O of n. Okay, good. So maybe I can optimize this. Let me think about it. I'm pretty sure I need O of n time because I have to take a look at each node. But for O of n space complexity, I'm not pretty sure I really need this. So let me think. So node 1 is pointing to node 3, like to that. So maybe I can do the copy of the linked list first, and then my task is to copy the random pointing without any extra space. Yeah. First I'm here, and this is pointing to node 3, and I actually can't do it. So node 1 to node 3, node 2 to node 3. Okay, so let me implement this algorithm first, and then I will try to optimize this. So here, copied head is this is the pseudo head. This is moving on the original head, original nodes, and this is moving on the copied nodes. No. Wait a minute. Maybe I can put the pseudo head in the given linked list, but I actually don't want to do it because if I do that, I'm mutating given list, which isn't so good. So let's say this is the edge case, and copied, this should be head.var. This is the copied head. And now current is pointing to head. Current 2 is pointing to copied head, which is not num. And while current one doesn't have any next node, copied next is this node. So actually I don't need this. So current two, wait a minute, let me move current one first. Then current two dot next should be a new node. Like this. Then I move the current two to the current two dot next. Okay, now current one and current two are moved. Good. Then here, what I would do is 2 pointers. No, line 30. So let me say here, I do it again. So firstly, I have to copy current ones. So copying. Oh, and as I said, I need the hash map. So copy head, and I need node mappings. So here I need like this. Then here, okay, this is it. So from here, I do implement line 74. So current one is not none. So current one dot random pointing. So current to random should be this one, and I need the mapping. I need to map this like this. So current two dot random should be pointing to this. Maybe I can just do this way. Then I move current one and current two. Pretty simple. Okay, and if current one is none, I don't have to do it anymore. Yeah. Good. Okay, so now I return copied head. Okay, so this is it. Wait a minute. So let me quickly change something here. I don't want to do this. Instead, current one is if current one is not none, current one is current one dot next. Yep. Okay, actually I can copy. No, if current one dot next is none, I cannot copy this. So yeah, I shouldn't do it. Okay, so this is it. So let me quickly dry run my code. I will think of the very easy case. Let's say this one. in this case, so head is not known. So I go to line 58. Copied head is node and head.var is 1. So like this. And node mappings should be original 1 to copied 1 node. Okay. And I go to line 67 and current 1 is pointing to head. And current 2 is pointing to copied head. Like this. I'm doing the first pass. So current one dot next is not known yet. So I move current one dot next. Current one to current one dot next. And in line 73, current two dot next is node current one dot var. So this one is created, and now current two is moved to. No, sorry, current two dot next should be pointing to this, and current two is moved. Okay, and in line 75, node mapping is done. So 2 to 2. This is actually node, even though looks like an integer. Yeah. So in the second pass, current one is head, and current two is now pointing to copied head. And here, firstly, current one, no, is not known. So current to random is equal to current one dot random. So current one dot random is actually known here. Oh, so in that case, what should I do? I should point to none. So maybe I should do add none to none here. Yeah. In this way, if current one dot random is none, like this, current two is now none. The current two dot random is pointing to none. Okay. And current one and current two are moved. Yep. Now I can see current one is not none, and current two dot random is node one. And from the mapping, I find copied one, which is this. So current two dot random should be pointing to this, like this. Okay, and current one and current two are moved, and then current one is none, so it's the end of the while loop. So in the end, in line 88, I return copied head, which is this one. Okay, so actually I passed this test case. I could completely copy the linked list and random pointers. So let me submit. Good. Okay, accepted. So let me quickly wrap up. So today I answered the question, copy list with random pointer. So in this question, my task was I'm given the linked list, and my task is to copy the linked list as a completely new list and return it. And the tricky part is that the given linked list has a random pointer. So I have to copy that random pointing also when copying. So for this question, I use the two-pass approach. So firstly, I copy the linked list. Then, aside from the random pointing, and in the second pass, I copy the random pointing. So in the first pass, I created the mapping from original node to copied node. So in the second pass, I could use that to find the randomly pointed node in the copied list. Okay, that being said, yeah, this is the unoptimized approach. So yeah, that's it.